What if I told you one man's forgotten invention turned waste gas into fuel and kept America's steel industry alive? Step inside Sloss Furnaces and discover how James Pickering Dovil's genius shaped the world we live in today. Did you know one man's forgotten invention turned waste gas into fuel and revolutionized America's steel industry? Hey guys, I'm William with Exploring History, and today we're beyond grateful to be back at Sloss Furnaces, a National Historic Landmark, walking the very grounds where history was made. There's nothing like seeing these colossal furnaces up close and learning firsthand how James Pickering Dovil's genius reshaped Birmingham's iron industry. Stick around, because by the end of this video, you'll see how one simple idea turned waste into power. And trust me, there's a surprising twist that'll make you rethink what industrial progress really means. At the height of its operation, Sloss Furnaces roared with fire and industry, its towering smokestacks releasing thick plumes into the sky. Inside, molten iron flowed like liquid fire, shaped and controlled by the hands of men whose lives depended on the very machines they tended. Among them was James Pickering Dovil, not wielding a hammer or shovel, but something just as powerful, an unrelenting vision for innovation. Though few may know his name today, his ideas transformed iron production, allowing furnaces to run longer, operate more efficiently, and waste less. Even in his final days, bedridden by illness, he remained committed to his work, taking calls from his hospital bed to instruct furnace operators across the country. His was a mind that never rested, a mind that turned obstacles into opportunity. This is the story of the man who revolutionized iron production in the American South and beyond. Dovil's path to innovation began long before he set foot in Birmingham. As a young man, he demonstrated an innate genius for mechanical problem solving. But what was it about Dovil's early life that sparked this inventive spirit?
James Pickering Dovil grew up on a farm, and while he was on this farm, he really began his career as an innovator. And throughout different problems that he encountered on a farm, he developed several things to assist in his farming chores.
At just 17, while still working on his father's farm, he designed a mechanical corn harvester. Though he never patented the invention, it was quickly adopted by manufacturers. Was this simple farm tool merely a glimpse of his potential, or the foundation for something much greater?
One of James Pickering Dovil's early inventions, the mechanical corn harvester, is one that really set the stage for his future life as an innovator in industry. Not only did it assist him and his family with their farm, but many farmers began using this piece of equipment all over the area.
This early spark of invention foreshadowed the brilliance that would later reshape the South. But it was not the quiet fields of Ohio that would define his career. It was Birmingham, the industrial giant rising in the heart of Alabama. In 1904, Dovil arrived in Birmingham, drawn to the promise of its booming iron industry. The city was growing rapidly, fueled by the relentless demand for iron and steel. One of his first major projects was overseeing the construction of the Woodward Iron Furnace, a site that would prove to be a launching pad for his later work.
In 1904, James Pickering Dovil came to Birmingham and oversaw construction of the Woodward Iron Furnace, one of the new furnaces they were building there. And that really set the stage for his work in Sloss Furnaces as he joined the company in 1925.
His leadership and innovative ideas would soon leave a lasting impact on one of the South's most prominent steel companies. To truly understand the scale of Dovil's impact, we visited Sloss Furnaces National Historic Landmark. Walking through the towering remains of the furnaces he helped modernize, surrounded by rusted pipes and machinery, We could almost hear the echoes of industry, of fire, of steel, of progress. This wasn't just a site of industrial history. It was a testament to ingenuity, a place where men like Dovil redefined what was possible. His legacy wasn't just written in history books, it was forged in iron. By the late 1920s, Sloss Furnaces faced a critical turning point. To remain competitive, the company needed to modernize, and it was James Dovil who led the transformation.
Sloss Furnaces began a modernization process in 1927 as they rebuilt the number 2 furnace, which is here on site. James Pickering Dovil, as the vice president, was hired to oversee this process. And in the process, he not only rebuilt the furnaces, but he designed them specifically to make it easier for southern ingredients to be made into iron and have a longer lifespan for the brick lining of the furnace, which made this company be able to make more iron longer.
This innovation meant fewer shutdowns, greater efficiency, and a significant advantage for Sloss Furnaces in an increasingly competitive market. Dovil didn't just modernize the furnace. He reimagined how it functioned from the inside out. To truly understand his impact, Ty led us to the towering remains of Furnace Number 1, one of the very sites where Dovil's innovations took shape. Standing at the base of the massive structure, surrounded by rusted pipes and aged brickwork, we could almost feel the heat that once radiated from its core. Ty explained a subtle but significant improvement that Dovil introduced, one that changed the way iron melted and gases moved within the furnace.
And so the inside of furnaces are kind of like a squat diamond. So it's a long top and then a very squat bottom, but it's a diamond shape on the inside. The varying degrees of slope between these sloping walls really determines how well iron melts down, but also how well gases rise in the furnace. So he was able to figure out the right degree of slope for the walls of the interior to allow the best gas rising through the furnace, which not only allows everything to move down smoother, but the gases at the top of the furnace start to reduce the iron ore before it becomes liquid. And so this just a changing of a slight degree of the slope really added in the efficiency of melting iron with these furnaces.
But efficiency alone wasn't enough. The furnaces needed to last longer. Ty motioned toward the exposed fire brick peeking through the rusted outer walls, explaining another major flaw of early furnace construction, one that Dovil set out to fix.
One of the biggest problems of older furnaces was the brick liner that lines the furnace. This furnace is, of course, made out of steel on the outside. Now, the temperatures on the inside, particularly right here where we are standing, which is the hottest part of the furnace, would reach about 3,800 degrees. So very, very hot. It would melt the steel that the furnace is made out of. So they put a brick liner with fire brick, like you might have in your chimney. Fire brick all around the inside, a couple feet thick, and you can kind of see some of this fire brick poking through the furnace here. Now, this brick was very important. It was the insulation, right? It helped protect the outside of the furnace, help keep it not as hot. The problem is old furnaces, you'd have to reline that brick liner about once every 1 to 2 years, which means you have to shut off the furnace once every 1 to 2 years. It's very expensive to reline it, and you're not making iron while you're doing it. And so it cost the company a lot of money. Now, James Pickering Dovil, when he started at Sloss, he thought this was an opportunity. How can I prolong the life of this brick liner?
Instead of accepting frequent shutdowns as an unavoidable expense, Dovil developed a groundbreaking solution, a water cooling system or water jacket. Ty pointed out how this innovation worked in real time,
which is really all these pipes all around the base of the furnace. Water now is pumped in between that brick liner. So there's pipes all throughout this brick liner, and the water acts as insulation to the insulation, right? The water helps keep the bricks preserved for much, much longer. And so with this system of the water pumping constantly through the furnace to keep everything cool, now the lifespan reaches about 5 to 7 years. So much longer lifespan, which means less time relining it, more time making iron.
This was a game changer. Less downtime meant higher production, lower costs, and fewer interruptions, exactly what Sloss needed to remain competitive. Iron production didn't just create molten metal. It also generated immense volumes of gas, filled with dust and debris, rushing upward at nearly 330 miles per hour. If left unfiltered, these gases were useless at best and dangerous at worst. But where others saw a problem, Dovil saw an opportunity. Ty led us deeper into the site, surrounded by towering metal structures where we could see firsthand the intricate system of pipes and chambers that made up Dovil's gas washing system.
One of the most prolific innovations that James Pickering Dovil brought to Sloss was his gas washing system, which is actually all surrounding us right now. We're in the midst of this complex system to recycle flammable gases out of the furnace.
The system was designed to clean and recycle the gases that surged from the furnace. As Ty explained, this process began with horizontal and vertical washers, where water was sprayed onto the gas at key intervals. The water collected fine particles of dirt, dust, and coal residue, allowing only purified gas to continue through the system.
Allowing the gas to be recycled through the site, burning off in the boilers and the hot blast stoves. This saved a bunch of money for the company because now they don't have to spend as much money on coal and on coke and on labor, as now they're able to use something that's already being created. It's free to them to use to fuel some of the other aspects of the site.
As we stepped closer, Ty pointed to the top of the gas washing system, where the horizontal gas washer came into view.
From here, we can really see just how complex this gas washing system was that James Pickering Dovil created for the company. So you can see on the top of the gas washing system here, this horizontal gas washer, there are lots of little water pipes all going in at specific intervals. And this was to allow the water to spray through the gas completely, allowing that water to settle at the bottom shape, W shape of the horizontal washer, so that you have the most efficient cleaning system possible and allowing that gas to continue to move through in order to get where it needed to go. Through this design of this horizontal washing system, you can see kind of the unique design of it. Almost looks like a filled-in W. So the two bottom peaks there, that's what would actually collect that dirt water. Because as the water and the dirt collect, or it fuse into one, it sinks down to the bottom as you're spraying through everything. And so it had a way for the gas to still move forward above that section and let the solid matter and the more mushy liquid matter sink to the bottom and still let that gas flow through so that it could be pumped out to where it needed to go.
But this innovation didn't just make iron production cleaner and more cost-effective. It also came with its own challenges. Ty gestured toward the thin wires running alongside the pipes.
Now it's also interesting that you see there's a walkway right next to all these little pipes going by. That's because somebody's job would have to go up there and repair them, maintain them. So it's not the easiest climb to get up there and do all that work that's needed to be done.
Dovil's gas washing system wasn't just an efficiency improvement. It was a revolutionary approach to sustainability in industrial production. By taking what was once considered waste and transforming it into a valuable fuel source, he helped Sloss Furnaces cut costs, increase production, and reduce environmental impact, long before sustainability became a global priority. Dovil's innovations reshaped Birmingham's role in the American iron and steel industry, forever changing the way furnaces operated.
When people walk around Sloss Furnaces and they see these technologies, they see this furnace site up close, it never ceases to amaze them. The engineering that had to go into a site like this to make this work. All the little parts and all the little pieces fitting together to make this 32-acre site work. And it's this kind of story that we want people to take away, especially the story of James Pickering Dovil, who was instrumental in so many of the parts of the site that you walk around and see today. So we hope that people who visit Sloss take away the importance of continuing to push forward technology so that our lives can be better in the future.
So as we look to the future, one question remains. What innovations today will redefine the world tomorrow? And who among us will have the vision, perseverance, and ingenuity to make them a reality? Though the furnaces of Birmingham have long since cooled, the spirit of invention they once embodied burns on. And there you have it, the incredible legacy of James Pickering Dovil, the man who turned obstacles into opportunity and helped forge the future of America's steel industry right here at Sloss Furnaces in Birmingham, Alabama. We're so grateful you joined us today on this journey through history. Nothing beats walking these grounds and seeing firsthand how innovation shaped the world we live in. And a special thank you to Sloss Furnaces, a National Historic Landmark, for collaborating with us and helping us bring this story to you. If you'd like to dive deeper into the history of Sloss Furnaces, be sure you check out our playlist right here featuring all our past collaborations with Sloss Furnaces. And hey, don't miss out this short blooper reel from this episode. You get a behind-the-scenes look at what it really takes to film a historic industrial site. It's worth a laugh, I promise. Until next time, I'm your host, William, and I can't wait to see you again when we explore history.